Hello, namaste everyone. Hope all of you are well. In the previous video, I have talked about entropy and the spontaneous reactions, especially if I talk about the spontaneous process in which there is no change in enthalpy, but it gives you the information about the direction. So, all the formulas in the previous video already I had informed you, and in this video, especially, I will go through the next topic, that is Gibbs energy and spontaneity. But before that, I would like to show you that what is the entropy, change in entropy. As in the earlier video I have already discussed about, delta S is equal to Q reversible by T. The total entropy, as you can see here, the total entropy change for the system and surrounding of a spontaneous process, it was given delta S total is equal to delta S system plus delta S surrounding, which should be greater than 0, right? But if I talk about the chemical equilibrium, then delta S is equal to 0. What is delta S? That is change in entropy. As you can see here, it's already written. But if I talk about the system and surrounding, which is not equal to 0, it is especially for irreversible process. So I hope in the previous video I have already discussed about all these things, and you have heard also and you have learned also about these things, that the total entropy change, total entropy means system and surrounding. So if I talk about the total entropy change, especially in the surrounding and system for the spontaneous process, delta S total will be delta S system plus delta S surrounding. Yeah. Now, as you can see, when the system is in equilibrium, now question is, how you can say that in this system, when it is in the equilibrium, it will increase or decrease? I hope all of you are able to get my voice is low because of this ear surgery. So please manage for a few days. After then I'll definitely make a video in the loud sound, but only for a few days it will be in a little bit low sound. So actually let us discuss about when the system is in equilibrium. When the system is in equilibrium, that time the maximum change in entropy will be 0. Now question is, when they will be equilibrium means what? Both the sides equal, there will be no change in entropy, so definitely delta S is going to become a 0. But if I talk about when the system is in reversible, then the change in entropy delta S is Q reversible by T. And but when the system is in irreversible process, that time you should remember the sum of entropy system and surrounding must not be equal to 0. As I have told you, here you can see delta S total is equal to delta S system plus delta S surrounding, which is greater than 0. It is not equal to 0. Either if I talk about the reversible and irreversible, you must remember all these things as I have already given you in the previous video. This is our next video. In this video especially, you can solve your NCERT numericals, which is given in the problem number 6.9 and 6.10. Both the numericals is very comfortably, you can understand about the entropy change. So the total entropy change is equal to entropy system, means delta S system plus delta S surrounding, that is entropy system plus entropy surrounding. These are the changes in the entropy. That's why there is written a delta S. You know very well, when there will be entropy applied, then there will be a change in the reaction. So that's why here delta S means the change in entropy. The change in entropy is change in entropy system plus change in entropy surrounding. Now let's come to our new topic, that is Gibbs free energy. Now you can ask me, sir, what is this Gibbs free energy, or the total energy change in the system? Can you, sir, please elaborate something? Definitely I would like to say you about that, what is Gibbs free energy. So as you can see on the board what it is written, I hope all of you can see. You can just see the Gibbs free energy. Yeah, Gibbs free energy for a system, it is the total entropy change, that is delta S total, which decides the spontaneity of the process. But most of the spontaneity of the process In a chemical reaction, it falls into the category of either closed system or open system. Therefore, the most of the chemical reactions, there are changes in both the enthalpy and entropy. It is clear from the discussion in the previous section that neither decrease in the enthalpy nor increase in the entropy alone can determine the direction of the spontaneous change for the system. As you have seen here, what are the changes, right? So here, first of all, I would like to tell you, see what is Gibbs free energy or Gibbs energy. You can see Gibbs energy and Gibbs free energy, there are two different things, but I will tell you these all the things later on. So first of all, let me introduce about this Gibbs energy, that there is no changing in the entropy, either it increases or decreases, and there will be no changes in the enthalpy also, either it increases or decreases. So as you have seen here, that is there any changes in the entropy or enthalpy? So there is no changes in the entropy and enthalpy yet here, as I have already informed you in the previous section also about the delta S total. So when I talk about the delta S total, you can see here it's written on the board, right? So here, if we, for the purpose, if we define a new thermodynamic function, that is the Gibbs energy from the function, and this Gibbs energy is denoted by G. What is this? Gibbs energy is denoted by G. So G is equal to H minus Ts. Gibbs function G is an extensive property and a state function, and the change in Gibbs energy for the system, that is delta G system, which can be written as delta G system is equal to delta H system minus T delta S minus entropy system delta T. See, whatever the formulas are written, just to remember these formulas, these are very important. So here, as I have told you about, G is equal to H minus T delta S, and it is an extensive property. So when we talk about the Gibbs energy change in the system, then delta G system is equal to delta H system minus T delta S system minus S system delta T. And if we talk about when the delta T is the constant, if we talk about the temperature is a constant, that time delta T is equal to 0. So as it will become a 0, then you know here delta G is equal to delta H minus T delta S, delta H system and T delta S system. Usually this subscript system is dropped, and we simply write the equation delta H is equal to delta G is equal to delta H minus T delta S. This equation you can see here, delta G is equal to delta H minus T delta S. So as you have seen here in this chemical Gibbs free energy equation, delta G is equal to delta H minus T delta S. This is the main equation. When we talk about this equation, that time we should remember that what is Gibbs free energy? It is an extensive property. As we have already discussed about the extensive property, what are these extensive property and intensive properties. I hope all of you have remembered these things. So here you no need to worry. Delta G is equal to delta H minus T delta S. This is the main formula of Gibbs free energy. You can see here it's written delta G is equal to delta H minus T delta S. This Gibbs energy change. Delta G means, what is the meaning of delta G? Delta G meaning is Gibbs energy change, enthalpy change minus temperature into entropy change. Delta G change means, that is Gibbs energy change, is equal to enthalpy change. Delta H is enthalpy. What is delta H? Delta H is enthalpy minus temperature into entropy change, and it is referred as the Gibbs equation. This delta G is equal to delta H minus T delta S is Gibbs equation, one of the most important equation in the chemistry. Here we have considered both the terms together for the spontaneity energy in the terms of delta H and entropy delta S. It is a major disorder and indicated earlier. Dimensionally, if we analyze, we find that delta G has units of energy, because both delta H and T delta S are the energy terms, since T delta S is measured as a kilojoule per Kelvin, or you can say that directly it is measured as a joule. Yeah. So as you have seen the Gibbs energy, in this Gibbs energy you must remember what is the main formula of this Gibbs energy. So delta G is equal to delta H minus T delta S, and this is an extensive property. Whenever you get these things, you should realize these things. What is delta H, T, delta S? Delta S is your entropy, T is temperature, and delta S is entropy. We have just taken together this all the extensive property, and we have formed an equation, that is a Gibbs equation. Delta G is equal to delta H minus T delta S. So now you should remember this formula. As we will do this formula when we especially will use in the numerical, that time we'll understand what are the importance of this Gibbs free energy. So we have understand the topic called entropy. So in the entropy section we have learned about the system and surrounding. As already you know what is entropy, that randomness, as already I had explained in the previous video also, and the total entropy change for the system and surrounding of a spontaneous must be greater than 0. So here change in entropy, that is delta S, means total change in entropy is equal to entropy of the system and entropy of the surrounding, right? So here this both value must be greater than 0, must be greater than 0. When the system is in equilibrium, yeah, you know very well, when system will be in equilibrium, then there will be nothing, so no change in entropy. So that's why here delta S value will be 0. Remember these words, why I am repeating, because the word which is going to come in numerical section are these words only. And if I talk about this thing is for reversible process, and if I talk about irreversible process, then also the change in entropy of the system and surrounding will not be equal to 0, will not be equal to 0. Now the new section, which let me introduce about a new extensive property called Gibbs free energy or Gibbs energy and spontaneous. You can see in your NCERT textbook the new topic. Before going to the NCERT new topic, the two things which I want to tell you is delta S total is delta S system plus delta S surrounding must be greater than 0 in a reversible process. In irreversible process it is not equal to 0, and it is in equilibrium, the entropy change is equal to 0. The value of S, remember delta S is greater than 0 in reversible process, not equal to 0 in irreversible process, and equal to 0 in chemical equilibrium. Now Gibbs free energy, it is an extensive state function or its extensive property in this thermodynamics sections. Here this Z is about the Gibbs free energy, which is equal to the heat change minus the temperature into entropy. This is Gibbs energy, this is your heat, and this is temperature, and this is entropy. So here when we talk about the system, delta G system, that is Gibbs energy in the system, that is the change in heat in the system minus temperature into change in entropy in the system minus change in entropy in the system into delta T, means temperature change here and here entropy change, and total here heat change. So if I talk about the temperature at the constant, then the temperature will be constant, T will be 0, delta T will be 0. So here Gibbs energy is equal to delta G system is equal to delta H system minus T delta S system, delta H system minus T delta S system. So the main formula is this is the main formula, remember everyone. So delta G is equal to delta H minus T delta S. This is the main formula of, if anybody will ask you what is Gibbs energy equation, delta G is equal to delta H minus T delta S. Now after understanding this concept, if I'll ask you about this thing, as you know very well, already I have informed you that total entropy is equal to the change of entropy in the system plus change of entropy in the surrounding. And if we put this change in entropy system and surrounding value according to the delta G, so what will happen? The delta S surrounding, that is entropy of surrounding, is equal to change of heat in the surrounding by temperature, that is equal to minus delta heat of the system by temperature. Why I have written this? You can ask me here a question, sir, why you have written here minus? You know very well, as I have already informed you, that when the heat will evolve from the system, then we have to put minus symbol, and when heat will go into the system, we have to put it. Since heat is evolving from the system and going into the surrounding, so that's the surrounding will be positive and system will be in negative. So I hope that you all have understand about this concept. Now actually I want to solve 1 2 numericals, but before that I want to complete these things. Just a second. So we have understand about the Gibbs energy. What is Gibbs energy? Gibbs energy is nothing else. It is the total amount of energy of the heat and system and surrounding, either in the spontaneous or non-spontaneous process. First of all, see, as I have already written right now only, that the total entropy of the surrounding will be the delta H surrounding upon T, which is also equal to minus delta H system by T, as I have written right now only. So here you can tell me that the total entropy is equal to system plus surrounding, and surrounding is equal to minus H system by T. So that's why I have written here minus H system by T, right? So as I will remove this bracket, then what will happen? Total entropy is equal to delta H system minus delta H system by T. Now I have arranged this equation by multiplying T delta S, means just I have multiplied both the sides with the T. So as I have arranged the equation, so what will be here equation? T delta S total. I have just put here T, and here T. Why I have put T? Because this I want to cancel. So that's why here T delta S total is equal to T delta S system minus H system. Have you understand? What I have just arranged this equation by multiplying T both the sides. In both the sides, left hand side also and in right side also. Left hand side, it became the T delta entropy total, that is equal to T delta entropy system minus delta H system. Now, if I talk about spontaneous process, then you know very well in the spontaneous process, the entropy value will be greater than 0, right? In the spontaneous process, the entropy value will be greater than 0, means delta S total is greater than 0. So here, as I have right now only written, T delta S system minus delta H system is greater than 0 for the spontaneous process, right? Instead of T delta system, I have written here minus delta H system minus T delta S system, which is greater than 0, especially for the spontaneous process. Okay. Now what was the Gibbs free energy equation? Delta G is equal to delta H minus T delta S. So here, by using the Gibbs free energy, if in the spontaneous process delta G is greater than 0, then what will happen? You know very well what is this Gibbs energy is the net energy of all these system and surrounding of the entropies. Got it? So here delta G value means the net energy of this whole equation, either in the system and surrounding, whatever the energy is there, sum of all these energies. So delta G is equal to net energy, and you can see here, if delta G value is less than 0, means negative. If I talk about the Gibbs free energy value is negative, then remember it is a spontaneous process. But if Gibbs free energy value is positive, greater than 0, then it is non-spontaneous process. So you should remember the word. What is Gibbs free energy? What is entropy? How we should calculate the entropy value? Where to put delta H system? Where to put delta H system upon T? How I have done this? All are mathematical calculation, nothing else. You can do it very easily. If you want to take a screenshot, you can take a screenshot. I hope all of you have taken the screenshot. Say, remember dear students, whenever you are calculating any problem, whatever the equations you are having, please write into the notebook. As you will write into the notebook, practice twice, practice thrice, you will get the concept. Till you are not getting the concept, don't stop your pen. Continuously do it. Write twice, write thrice, tetra time. Till whenever the concept is not going in your mind, till that time you have to continue. Okay, now this all was Gibbs energy in the spontaneous process. Now, as in the entropy 1 to numericals was there in the NCERT. See, your numerical is, you have to just see that predict which of the following entropy increases or decreases. I hope that you all have done. A liquid crystallizes into solid. What will happen? A liquid is crystallizing. Crystallize means liquid to solid. The molecules will attain the order, right? So you know very well, if molecules are coming closer to each other, the entropy will be decreased, not increased, right? So here that is given only in your problem 6.9 in the NCERT. So here a liquid crystallizes into solid means entropy will decrease. Second question, temperature of a crystalline solid is raised from 0 Kelvin to 115 Kelvin. Yeah, this is the good question. As it will raise the temperature, the crystalline will convert into the liquid. Then definitely entropy is going to increase. Correct? What will happen? They will become disorder, and disorderness is only known as entropy. Yeah, so definitely entropy will increase. The third question is sodium bicarbonate, it breaking down into the sodium carbonate, carbon dioxide and water. Now, a very good question. Here they are asking you that entropy has low in the solid state, and in the gaseous state the entropy has higher. So when this solid breaks down into the solid and gaseous, so in the solid it will be entropy will be lower state, and in the gaseous it will be the maximum state. And last one, H2 into 2Hg, means one molecule is breaking into the two atoms. So there will be more disordered state, and the entropy of 1 mole of dihydrogen molecule will be disorder. So you can understand that entropy will increase only. So this was a question I think that you know very well. See, remember about the entropy, Gibbs energy and the spontaneous reactions. I hope you will understand this concept. If you have any doubt related to this entropy and spontaneous reaction, please drop your doubt into the comment box section. That's all for today. Thank you very much. Don't forget to like and subscribe the channel. That's all for today. Thank you.